Assalamualaikum. Thank you to all panel. Today I will present research methodology and pre-project. My research title is Seismic Performance to Truss Bridge under different earthquake loading. My name is Mohd Fajar bin Muhammad Jaffar. My supervisor is Engineer Dr. Safwan bin Wan Ahmad. Introduction. What is an earthquake? Earthquake defined as a ground shaking caused by sudden release of energy in the earth crust. Movement of the surface of the earth causes when the road underground suddenly break along the fault. The release of energy causes the seismic wave that make the ground shake. The disaster causes significant damage to the environment, building and properties. Earthquake happen. An earthquake is caused by a sudden slip on a fault. The tectonic plates are always slowly moving, but they get stuck at their edge due to friction. The stress on the edge overcome the friction, release energy in waves that travel through the earth crust and cause the shaking. In figure 1 shows the location of Peninsula Malaysia on the Sunda plate and the seismic sources around it. We can see the red line is the fault line, the blue line is the Sumatra fault line, and the green area is the Malaysia region. This is the list of the major earthquake recorded by seismograph. Figure 2 shows the correlation between magnitude and energy release, adapted from Mohd in 1999. Earthquake frequency and destructive power. The left side of the chart shows the magnitude, and the right side shows the energy release, and the middle shows the number of earthquakes per year worldwide. We can see the Chile in 1960, the highest magnitude earthquake happened around the world, and followed by Alaska and Japan. The earthquake impacts damage the structural buildings, damage the infrastructure, which is the bridge and the highway. The causes of the earthquake also cause the slope failure, liquefaction and tsunami, produce the seismic wave with the wide range of frequency. You can see at the Kobe, Japan in 70 January 1995, which is with the 6.9 magnitude strike slip fault. Total damage around 200 billion US dollar. At Malaysia, at Sabah, Sabah in 5 June 2015 with 6.0 magnitude deep slip fault. Total damage around 2.84 billion US dollar. Truss bridge. Truss bridge is a loading bearing superstructure consisting of a series of wooden or metal triangle as known as a truss. A triangle cannot be distorted by stress. Truss also provide a stable structure that capable of resist external load over the large span. The members of the simple truss are only subjected to tension and compression force. Commonly, type of the basic design used are Warren truss, prop truss, Howard truss and K truss. In this picture is the Warren truss. My problem statement in the research is: first, design of the bridge in Malaysia is known to have a lower intensity of seismic effect. Secondly, structural capacity of the building in Malaysia able to resist the earthquake without failure. And thirdly, vulnerability of a truss bridge to seismic effect. My objective in this research is first to study behavior of the truss bridge under far-field earthquake and local earthquake. Secondly, to study the resistance of the existing truss bridge structure using the vulnerability assessment. Thirdly, to study the dynamic characteristic of truss bridge under different type of loading. My scope of study is the truss bridge structure, structural modeling by SEP 2000. The data used in this research is from Malaysia Meteorological Department MMD. Load consideration, live load, dead loads, earthquake load, which is the Aceh data, El Centro data and Kuala Lumpur data. The type of analysis, free vibration analysis, time history analysis, response spectrum. Significance of study. To study the effect of seismic towards truss bridge under earthquake loading, study the behavior of the truss bridge due seismic response, study the safe design of truss bridge under earthquake loading, and study the implement seismic design of structure to resist the earthquake loading for the truss bridge. The literature review 2019 seismic design of bridge against near fault, ground motion using combined seismic insulation and restraining system of LRB and CDR. The author is Lee and Zioli. Related study of summary, this journal article is discussing about seismic insulation design for a near fault actual highway bridge in high intensity earthquake zone peak of a ground acceleration PGA 0.4 G was developed. Methodology. Start the project planning, data collection, SEP 2000 model structure, free vibration analysis, time history analysis, response spectrum, result and discussion from analysis, and make the conclusion and end the thesis. SEP 2000. To analyze and design software most of the structure which can provide 2-dimensional and 3-dimensional model of structure. Secondly, this intuitive interface allow to create structural model rapidly without long learning curve delay. Thirdly, the loading such as seismic winds and waves can be included to be generated to the structure. And lastly, programming will provide an output of the model structure, displacement, bending moment, and shear. Methodology. Truss bridge drawing model. This is not the actual drawing, but I make consideration and discussion with my supervisor. The length of the span around 30.7 meter. The height of the truss from top to bottom around 4 meter. This is the deck section and the truss bridge joint. Diagonal, deck beam, vertical, and the grider. This is the connection of the truss bridge for the top members and bottom members connection. We can see the bob connection. Computational software SEP 2000. Type of analysis is free vibration. The method is 12 model. Time history, ground motion of Ecentro and Kuala Lumpur earthquake. Response spectrum, Eurocode 8 2004. The expected result from this research is mode shape of the truss, maximum shear stress and bending moment, joint displacement, velocity and acceleration under different load combination. This is my planning and schedule from week 1 until week 15 for my research. That's all from me. Thank you to all panel.